Alright guys, so we are back for quarter 4. Remember this one we are just doing straight ACT practice, so it's not going to be one skill at a time. It's mixed skills. So, for the first couple weeks I'm going to tell you which questions are which bucket, but then you're going to have to identify them on your own. So, let's start with number 12. Which of the following straight chain hydrocarbons would not be a gas at room temperature? So these are straight chain hydrocarbons, and then room temperature is what? 21 degrees Celsius. So room temp is 21 degrees Celsius, and we want it to not be a gas. Now this is going to require us to do a couple things. One, it needs to have boiled at 21 degrees to be a gas. So it's not a gas if the boiling point is lower or is higher than 21 degrees. So, negative 162, negative 88, negative 42, 0. All of these would be gases. 36, it would not be a gas yet, not be a gas yet, not be a gas yet. So, of the following, C2H6 was a gas, C3H8 was a gas, C4H10 was a gas, C5H12 was not a gas. So the answer to that one is J. Now, this one is an IOD question because you just need to pull information from the chart. So my answer is straight in the chart. There was no guesswork here. It did ask you to know some science though. So this one was difficult because science is involved. All right, 13. Which of the following conclusions is supported by the observed results? Anytime you see this, conclusion supported, it's an EMI question. Okay, boiling point varies directly with molecular weight. So let's see. As this increases, what is this doing? It's increasing, so yeah. Let's see here. This one is a little bit different though because we have to reorder it. So lower, lower, then we'll go to 32, 112, 34, 77 is 90, 78 is 55, 162. Yep, that one does the same thing. So as that increases, this one increases too. So we can say that. Directly means they both go in the same direction. So that means we know 2 is wrong because inversely means when one goes up, the other goes down. Boiling point is affected by molecular structure. Can we prove that? Well, the boiling point is different for each formula, right? So, yeah, I would say that one too. So that means our answer for 13 is C. 1 and 3 only. All right, number 14. Based on the data in Table 1, so we're only going to look at Table 1, the boiling point of the straight chain hydrocarbon 6C6H14, molecular weight 86, is most likely. This is IOD. Specifically, that's IOD 404 because you have to interpolate between it. So, C6H14 would fall in between these two values, C5, C8, and 86 falls in right here. So that means our boiling point needs to be between 36 and 126. So nope, too high, too low. Our answer is G. That's IOD 404. But again, IOD because the answer is a number from the table. All right, number 15. Based on the data in Table 2, so we're going to look here, as molecular weight increases, the difference between the boiling points of polar and non-polar substances of similar molecular weight does what? Now again, this is a trend question, and trends are always IOD. IOD is the most common thing on your ACT. You're going to see that the most, just FYI. So, now, polar and non-polar. Non-polar has 1 star, polar has 2 stars. So we'll split this into 2. My 1 stars, as they increase, this one increases. My 2 stars, as they increase, This one also increases. But this says the difference between the boiling points of polar and nonpolar substances of similar molecular weight. So 196, 192, that's a difference of 4. 112, 85, that's a bigger difference. 90, 55, that's a bigger difference. 59, 97. So it increases. The difference between them increases. If we look at that for the 28-ish range, it's negative 196 and negative 192. For the 30s range, it's negative 112 to negative 85. Do you see how these are further distances apart from each other, these numbers? That's what it means. So that question is really confusing. You might have to read it a couple times, but the answer for that one is A. And finally, our last question. I'm going to do it brown again. A polar substance with a boiling point of 0 degrees Celsius. This is also still IOD because you're going to pull out a number. Almost every time that you're asking for a number, that it's going to be an IOD question. So, a polar substance with a boiling point of 0 degrees is most likely to have a molecular weight close to which of the following? So, I'm going to go to my table. I'm going to find my polar substances. That's 2 stars with a boiling point of 0 degrees. So 0 degrees falls in between here. So that means that its molecular weight needs to be between those values, 78, 162, negative 55, and 97. I'm going to put a number line here. Negative 55, 0, 97. This was 78, I believe. 78, our thingy, 162. Okay, the 0 is closer to this number than it is to this one, almost by half. That's basically 100, that's basically 50, so it's 2 times further away. So that means we're going to be way closer to the 78 than we are to the 162. So 58 is too low. And then all of these numbers are between G, H, and 132. So the difference here, what's 162 minus 78? Any takers? I don't want to do this in my head. I really don't, but whatever. Okay, so if you take your difference here, in the numbers, then you're going to divide that number by 3. You can eyeball this. You don't actually have to do the math. But if you want to do the math, then you would take your number. So that's 84, right? I did it in my head. I just really didn't want to. So 84, and you divide that by 3. That one I'm not doing in my head. I'm going to use a calculator for that one. So that's 28. So you'll have 28, and then you'll have your 52 on this side. So 78 plus 28. Oh, oopsies. My calculator was wrong. 78 plus 28. If you guys can do this in your head, great. I just don't want to right now, so I'm using a calculator on my computer. But that's about 106-ish. So you would go there. Now, if you did not want to do the math to figure out the answer directly, you can always eyeball it. For the answer of H, 80 is too close to 78 because you needed about 1/3 of the way between those two numbers. And 132 is too close to 162. Now, you do not have to do what I did. That's just so I can thoroughly explain the difference between these. You can literally just eyeball it. So on my number line, I have like 1, 2, 3 differences because the difference here is 150-ish, right? Like rounding it. And then we have the 50 here and 100 here. So you divide it into thirds. There should be 1/3 on this way, 2/3 on that side. So you can take it with the numbers, but 162 to 132 to 162 does not give you 2/3. So you can figure it out that way.